Hello, everyone. Thank you for joining us today for our ALS Webinar Wednesday. My name is Alex Yao. I'm the marketing coordinator for ALS North America, and I'll be facilitating the webinar today. Just a few helpful notes before we begin. If you are having technical issues with our webinar platform or any questions, type your message or question using the chat function at the bottom of the screen. You can also select the hand icon to notify me of your status so I can assist you. All questions regarding the webinar material will be answered at the end of the presentation. Our presenter today is Geraint Williams. Geraint is the global PFAS practice lead for ALS. He has over 25 years experience and is the chair of the Network of Industrially Contaminated Land Europe's PFAS Analytical Working Group. He's also the chair for the Association of Geotechnical and Geoenvironmental Specialists Contaminated Land Working Group. Geraint also works for the United Nations Environment Program Post-Conflict Branch. He's carried out investigation of sites in Nigeria, Iraq, Cote d'Ivoire, and many other countries. Today, Geraint will be discussing the latest approaches to investigating PFAS-impacted sites. Thanks for taking time to deliver this presentation. I'll turn it over to Geraint now.
Many thanks, Alex. That's much appreciated. Thank you very much for giving me this opportunity to talk about this very important subject today. I think Alex has covered very well my kind of background. I think he'd mentioned I'd worked for ALS for 25 years. That's definitely the case. So I've been very fortunate. ALS have allowed me to be involved in a lot of these kind of additional extracurricular kind of activities with these different working groups. So I've been very fortunate over the years to be part of these groups. There was one other kind of group that I am involved in. I do sit on a number of international European and British standard committees. So there is one actually, there's an ISO standard which relates to PFAS analysis that I sit on. Actually, it's coming up next month actually. So I will perhaps provide an update on anything of interest from that particular standards committee in the future. I also want to just to draw your attention to a new guidance document that's coming out. It is UK focused, but it has some of the most recent kind of updates in terms of the most recent toxicological updates. It's in reference to what's called the Construction Industry Research and Information Association. It's called CIRIA. I think it's close to a 200-page document. So as I said, it kind of reviews the very latest guidance out there, and as it relates to things like preliminary risk assessment and detailed quantitative risk assessment. We look at remediation, and we do focus quite a lot on site investigation, site characterization, laboratory analysis. So I'd said it might be a UK publication, but it's certainly got some relevance to the US because it does look at the very latest approaches for all these different aspects. So I think it's probably going to be coming out perhaps later this summer, maybe in the fall. So please look out for that. It would be really useful to have a good look at that particular document in the future. So this presentation it's relatively short. I've tried to keep it as concise as possible. Perhaps we should start off by saying that, you know, as with all kind of site investigations, it's a robust site-specific conceptual site model that remains a basis for kind of understanding any risks on PFAS contaminated sites. You know, that same would apply to any types of contamination that we're looking at. But in terms of PFAS in particular, I think the assessment of these types of sites, we need to make decisions on the most reliable, the most defensible data. Obviously, there's a lot of kind of liability associated with PFAS, even more so than some of the other contaminants that we're looking at. So I said this presentation focuses on how we collect soil samples, how we collect water samples. But I also wanted to discuss concrete because that has a particular issue. I think there's a lot of focus on that at the moment as a secondary source of contamination on a lot of sites at the moment. So, you know, we could investigate these sites. We could spend many hundreds of thousands of dollars in terms of remediation. But if we're missing this secondary source of contamination, all our work's in vain, really. So I just wanted to highlight that. We've got a kind of a quite just 2 or 3 slides, just case study on PFAS in concrete. But I also wanted to make you aware of this issue where I'm sure everybody realizes that there's this high potential for cross-contamination. But just wanted to highlight that previous guidance. A lot of the kind of states a couple of years ago, maybe 4 or 5 years ago, we published a lot of useful guidance, but there was an abundance of caution written into those kind of guidance documents. And I think more recent guidance, I think it's more risk-based, it's more pragmatic, so it does take into account what the actual sources of contamination might be. We already know that, PFAS, individual PFAS can be different. They can have different physical, chemical characteristics. So that has implications to the way that samples should be collected. I also wanted to just touch on a class of PFAS, which I don't think are widely talked about in the US, but they're certainly getting some attention in other parts of the world. These are the fluoroethyl alcohols, or the FTOHs. So those definitely have different physical characteristics to some of the other PFAS we're more familiar with. But just generally, and PFAS in a lot of sites, it can form these kind of complex mixtures, certainly in source zone soil, source zone kind of groundwaters. And because PFAS can be very mobile in groundwater, they've got this high potential for transport. And often that kind of mobility is linked to the chain length. So short chain PFAS tend to be more mobile than longer chain PFAS. So when we're investigating these sites, we need to take into account that it's often a more extensive investigation. So the kind of boundary of the investigation has to be more extended than when we're looking at more conventional standard kind of contaminants. And equally in soils, we see sorption of some PFAS in organic carbon, and that kind of increases with the perfluoroalkyl chain length. So, the longer chain PFAS are more likely to stick to soils and sediments. But there's also a little bit more kind of complications in fit and transport characteristics. So we have to look at things like electrostatic interactions, and that can be important for certain groups of PFAS, like the cationic and zwitterionic PFAS. So it's just it's a more complicated picture when we're looking at PFAS impacted sites. We can expect PFAS to be present at higher concentrations in that kind of air-water interface. And there's been a lot of kind of studies which are focused on the surfactant properties of PFAS, but I'm sure most people on the call are already aware of that. And there's further research being carried out on PFAS interactions with other contaminants. So we have to think about other co-contaminants that might be present. I think there's a lot of work by CERDIP which have been focused on concentration of PFAS with NAPLs as well. So again, it's a more complicated picture. And I'm also going to hopefully pull everything together in a conclusion, and we can summarize a lot of these points. But just in terms of a general overview, again, I'm sure most people are aware of this. As I mentioned, PFAS can be very mobile in groundwater. So their mobility is one of these things we really need to be aware of. And one of the key exposure pathways is impact to drinking water sources. So from surface water to groundwater to kind of drinking water sources. And they can biotransform the environment, but show little signs of biodegradation. So, we've got these issues where the polyfluorinated substances can biotransform the environment to the more terminal products. So we've got a particular method that we look at called TOP assay, total oxidizable precursor assay. If you want to know a little bit more about that, we did have a separate presentation which covered the kind of pros and cons of TOP assay as a methodology for carrying out lab analysis. But some of the longer chain PFAS is certainly the most studied, the most regulated, the PFASs and the P4 of the world. They are known to be more bioaccumulative. So a lot of the toxicological research has been done on those particular PFAS. And they're interesting from a toxicological point of view because they've got known kind of causations of reproductive, developmental, liver, kidney, immunological kind of toxicities. So there's a lot of published research out there on that kind of toxicological issues around PFAS. But they can bioaccumulate in proteins, which is different to a lot of the other persistent organic pollutants we might be a little bit more familiar with. We've got this particular issue with humans because we can absorb PFAS and they'll end up in our system for a lot longer because we've got this 4-compartment kidney. And you get this issue with renal reabsorption of PFAS. So from a toxicological point of view, there's a couple of things we need to be aware of as well.
Can I just jump in, Geraint?
Sure.
Are your slides? Are you advancing through the slides? I think we're stuck on your other screen.
Oh, sorry. I'll see. Can you see my slides now?
We just see your PowerPoint.
Let me see what I can do there. Apologies for that. Can you see that now? Has that made a difference?
No, can you try resharing your screen? I think you might be sharing your main monitor and not the one that's being presented on. Um, Still showing your PowerPoint screen. You might just, there we go. There we go.
Okay, sorry about that, everyone.
Yep.
Hopefully you can see. Can you see that now?
Yes, everything looks good now.
Perfect. Sorry about that. Okay.
No worries.
So we were talking about sources of PFAS. So there's many sources of PFAS. There's many sites where PFAS are contaminated. So one of the most dispersive uses of PFAS is often firefighting foams. So wherever firefighting foams have been used in the past. So I'm thinking about the kind of normal sites where we're looking for PFAS as contaminants of concern. So these are airport sites, these are former military sites, oil depots, fire stations, etc. These are the kind of common sites where we're looking for PFAS. But to be honest, if there's any large building or warehouses where there's been a sprinkler system, so things like breweries, even vehicle manufacturing workshops, there might be PFAS that could have been used in those kind of sites as well. Aircraft hangars. I've been involved in the investigation of aircraft hangars in my time. We often see quite significant quantities of PFAS from fire suppression systems in hangars. Also primary sites, so anywhere there's manufacturing of PTFE, for instance. And one of the big issues we're seeing at the moment is conventional wastewater treatment processes. They have some real difficulty treating PFAS. And we see some up concentration in biosolids when kind of the biosolids are applied to land as an agricultural fertilizer. And there's a wide range of applications for PFAS outside of that as well. You know, they've got many advantages. They've got water resistant properties, oil and grease resistance. So in those kind of contexts, we've seen textile manufacturing works, cardboard manufacturing, paper manufacturing, all these other types of industries where their particular advantages are used for that purpose. But PFAS have also been used in like mist suppression to prevent air emissions from toxic fumes from chrome plating works. So you see certain types of PFAS like 6,2-FTS and a particular type of PFAS called F53B. PFAS are often found in landfill leachate. So we've done quite a lot of work working closely with the regulator in the UK. And we're finding a lot of the dominant PFAS in landfill leachate is one particular type. It's called 5,3-fluoroethyl carboxylic acid. And that's from the historic practice of burying carpets in landfill sites. And I mentioned this kind of new group of PFAS, these fluoroethyl alcohols. And again, they're often associated with wastewater treatment works and landfill sites as well. So what is the issue? What is the problems? What are the challenges in terms of sampling when we're looking at? So there are quite a few challenges, to be perfectly honest. There's an increased potential for cross-contamination to occur when we collect samples. And what do we really need to be aware of? So in terms of cross-contamination, if you describe cross-contamination, we're thinking about the unintentional introduction of PFAS into samples during things like collection of samples, during shipping of samples, during storage, and even in the lab analysis of samples. So there's a number of issues we need to be looking out for. And therefore, additional considerations we need to take into account when compared to sampling other contaminants. So why is this the case? Why do we need to be more careful with PFAS? Well, first of all, we're looking at much lower generic assessment criteria. And sorry if that's a term that's used in the UK rather than the US, but, you know, those kind of threshold levels, those kind of levels which are important from a regulatory point of view. So often, you know, when we're looking at those kind of low levels, waters, we're looking in the PPT range. And in soils, we're often looking in the PPB range. So PFAS can exist in sampling locations orders of magnitude higher than that. So when we're looking at that from an assessment criteria point of view, we need to be aware of that and that kind of level of decontamination that's used. Because of the potential for cross-contamination, we have to have a more robust system of decontamination. We need to check that by doing quality control samples, equipment blanks, etc. which we're going to talk about a little bit later on in the presentation. I always say planning and preparation is key to a successful site investigation. So hopefully this slide prompts us to think about the questions we need to ask before we actually investigate a site. So there's just a limited number of examples just here on this slide, but it's often the questions that should be asked of a lab. And that should be included in things like the project work plan or the quality assurance project plan. So we know what potential contaminants of concern are from the site history. You know, the previous slide that we looked at, we're looking at the kind of main contaminants of concern from that particular slide. So it's about establishing project data quality objectives and communicating them to the site teams in the field, but also that communication with the lab is really important. And I'll try and emphasize that as much as possible during this presentation. But obviously, this should be done prior to collecting the samples. And the analysis, you know, that kind of conversation with the lab is important before we actually take those samples. So it's important to look for the correct suites of analysis. It's important to have the right sensitivity in terms of the analysis that we choose. And it's also important that all these questions are kind of asked, you know, which PFAS are being included in the method? Is the limit of detection low enough? Can the lab provide PFAS-free water? What proficiency testing schemes are the lab involved in? All these questions are important questions to ask. But it's not the complete list. It's just a couple of example questions. But this is always done at the kind of planning stage before we go out to investigate these sites. So I wanted to just have a kind of a brief kind of look at some of the equipment that's used and the kind of approach we take when we're looking at this equipment. So there's relatively a limited number of studies looking at the content of PFAS in sampling equipment and the ability of those kind of contaminants to cross-contaminate the sample in the field. But I know there's been more recent studies, and I'm sure there'll be more studies carried out in the future on this particular topic. But as I said, you know, previous guidance took a very conservative approach to what equipment can be used in the field. But a good place to often start is to look at the safety data sheet. So it tells us some of the kind of story, but perhaps not all the story. So if you look at the ingredients described, so if you see the word fluoro, for example, described as one of the ingredients in a particular type of equipment or particular fluid that's used, a decontamination fluid that might be used in the field, that's a good indicator that we might have a particular issue with that. But I would say it doesn't always confirm absence. So if these are not listed PFAS, if these are not listed, it doesn't actually mean that they're not there. So we still need to do some level of testing. We still need to do some level of quality control. So, you know, there's often things where we need to look at in a bit more detail. They could be used in the process, or they might be cross-contaminated. They might be stored in an environment that causes the cross-contamination. So in itself, it doesn't always paint the full picture. But if there's any uncertainty about whether the equipment is going to cause cross-contamination, this is where quality control samples really come into play. And I would really focus on this as something we need to focus on quite a lot. So we need to ask the lab if they can carry out the analysis of this equipment. And we've actually had some requests quite recently for some of the components that are used in the construction of monitoring wells. It's a geotextile that's used in the construction of monitoring wells. So we've actually been able to analyze that. We were going to do kind of a leaching test on that particular type of material to make sure it doesn't cause cross-contamination. So as a lab, we can help with that, we can support that. And yeah, that's something we can help out with. But also, it's kind of a tiered approach. So we need to really focus on what materials come into direct contact with the sample. I think that really should be the focus of our attention. And perhaps less so some of the materials that are not going to come into direct contact with the sample. And a lot of the guidance, a lot of the more recent guidance kind of emphasizes those points. So when we're looking at kind of sample containers, I'm sure a lot of people are aware of all these methods. And I know ALS produced some helpful guidance documents in terms of what containers to use for what particular type of methods. So I would emphasize that point that communication with the lab is very important. But most of these kind of PFAS methods, they have requirements for the types of containers that are used and also the kind of required volumes, the types of preservation, especially on the drinking water side of things. So as listed, it's important to be aware of what types of containers are used. And for aqueous samples, we're using more than one type of sample, or more than one container for each sample that we take. In terms of the lab methods themselves, so 537 and 533, these methods require use of preservatives, and the methods are prescriptive. And we're seeing these particular two methods used in UCRM 5, and that requires both of these particular methods. Well, when we look at 1633, which again you might be very familiar with as well, this is a bit more complicated. We're looking at 40 PFAS, and the holding times were actually evaluated to samples which were stored at 4 degrees and minus 20 degrees. And the holding time study highlights losses and also, interestingly, some gains as well. So I think that's most likely from the conversion of the precursors in the sample. And there's one particular type of PFAS, NFDHA, one of the ether carboxylic acids, and that had quite a short holding time. And I think that there was potential for that, more in the solids and in tissues. But I think that had there was an issue around kind of holding times for that, and significant losses were noted in a relatively short period of time. So if you're working outside with that as a particular contaminant concern, then just be aware, and we need to analyse that as soon as possible. Now, I did mention the fluoroethyl alcohols. This is an important class of PFAS, which we've just been able to develop a method for. And I said it's a well-known precursor to the PFCAs. So these particular type of PFAS, like P4, PFHXA, for instance. And there's several potential sources. We talked about kind of landfill, sewage treatment works, etc. But these are neutral PFAS. These are volatile PFAS. And they have to be sampled in a slightly different way. So they're too volatile for liquid chromatography, the standard kind of method that we use for carrying out PFAS, for carrying out analysis of conventional PFAS, because they've got kind of low boiling points and they've got high vapor pressures. So we're actually using a GC method for carrying out the analysis. So because of that, samples have to be collected in a different way. We use volatile vials with 2 mils of methanol, because of the stability of these kind of PFAS. So as I said, the vials have to be filled to maximum capacity, but because we've got methanol there, we don't overfill the vials. And samples should be returned to the lab as soon as possible. So something extra to think about when we got these issues with fluoroethyl alcohols on some sites. So sampling considerations, it's good practice, really. If you're familiar with investigating some sites, good practice is consider the kind of overarching objectives of the investigation, and take those into account when we're developing our outline conceptual site models. And this will influence the sampling plan. So think about the site history, think about the potential sources. So if you're working on a former airport site with a fire training area, for example, think about the potential pathways. Also think about sequencing of samples. So think about taking drinking water samples first, then surface waters, then groundwaters, and working towards the most contaminated samples last. So you're minimizing that potential for cross-contamination. So if you know you've got high concentration samples, those would be segregated from shipping. So those should be put in their own cool box. And again, there might be a level of caution applied to that, but I think it's just good practice. You might already be quite familiar with the kind of practices for taking drinking water samples. I'm not a specialist in taking drinking water samples, but that kind of established good practice is, removing any tubing or removing any external connections, collect from the cold tap and allow the water to run between 3 and 5 minutes. Samples should be collected from the water that's flowing. Do not allow the sample to overfill from the bottle, and shake the sample to dissolve any of the preservative that's present there. And we know that PFAS have surfactant-like properties. We've already mentioned that. So that means they can accumulate in the kind of air-water interface. And PFAS can be enriched. And there's been a lot of studies actually been done on this particular phenomenon as well. But it can be enriched in the kind of micro layer of surface waters. And we're seeing kind of, to give an example, in Europe as well. So Danish regulators observed really kind of concentrations of 1 nanograms a litre in the water, but actually about 120,000 nanograms a litre in the foam. So there's a big difference between what layer of the water you actually sample. But consider whether it's appropriate to collect samples from the bulk water, or whether we should focus on the kind of worst case conditions, which could account for the surface water micro layer as well. So it depends on your risk assessment, really, to determine whether direct contact with foams is one of those issues we need to collect samples for. Whether, you know, swimming in the water, for example, is one of the kind of key exposure pathways. I'd say stratification is less of an issue with groundwaters. So it's not so much of a problem when we're looking at groundwaters, but PFAS can have these kind of complex interactions with NAPLs, as I mentioned. And for groundwaters, it's often better to use low flow techniques because that minimizes turbidity in the sample. And no purge techniques or passive sampling, those are appropriate as well. ALS have developed a method for carrying out analysis of passive samplers. So it was an environmental that's been published on that. So I'd refer you to the environmental if you had a particular interest in passive sampling. And in site investigations, I already mentioned that, you know, we need to be aware that the fit and transport characteristics of the polyfluorinated substances are different to the perfluorinated substances. So, you know, as mentioned, there's detergents that are used in our decontamination processes that have the potential to contain the fluorosurfactants. So we need to be aware of that. And I think the kind of very latest guidance out there is to use things like Alconox and Liquinox and Citronox. Those are approved kind of decontamination solutions. So I'm quite familiar with using things like Decon 90 or Nutricon, and those there's a question mark about whether those can be used. So refer you to using what is approved, the Alconox, the Liquinox, the Citronox, etc. And always use the lab's certified PFAS-free water. It's not practical sometimes to use that kind of water for rinsing down large equipment like drilling rigs, but as a final rinse, use that water. If you use any other type of water, you need to test that water. So even if you are using that to decontaminate drilling rigs, test the water beforehand to make sure you're not causing cross-contamination. In terms of the types of quality control samples we need to be aware of, there's just a couple of examples here. But why do we need to take quality control samples? Well, really, we need to take quality control samples because it gives us a higher degree of confidence in our data. So if we're decontaminating, we need to make sure that we're decontaminating adequately, we're not causing cross-contamination. As I said, I've listed some of the typical QC samples that are used, but other QC samples can be collected. Additional quality control samples are often determined by the site-specific work plans, or often by the kind of data quality objectives that have already been developed for your particular site. Not mentioned on the slide, we have a possible requirement of the kind of pre-investigation blank. So I've talked about before, taking samples beforehand to make sure that we're not causing cross-contamination. But equipment blanks are very frequently used to assess the adequacy of any decontamination procedures. So these are blanks which involves rinsing equipment with deionized water and then collecting the water after we've done that. They're not required for drinking waters because they're collected directly from the source. But if you're using a trial, for instance, I would say it would be appropriate not to take that many equipment blank samples if you're just using a trial in the field, because that can quite easily be decontaminated. But if you're looking at more frequent blank samples, you'll be looking at kind of groundwater sampling equipment, because it's often a lot more difficult to decontaminate the components of any kind of groundwater monitoring kit that's being used in the field. So take more regular, more frequent kind of samples. But when we're looking at field blanks as well, this is where PFAS is, this is where deionized water is poured into sample containers. And that helps us determine if sample collection, sample handling, sample storage, etc., can be the source of cross-contamination. So that's the main reason for kind of taking field blank samples. I also wanted to point you in the direction of some recent guidance. I know we talked about some recent guidance before. There's been 3 or 4 really useful papers that have been published before these 2 guidance, which are on the screen there. So there's a couple of papers that were published by Bartlett et al., Denley et al., and Rudunda et al. So those were often the kind of leading into some of these, often quite widely referenced in these 2 particular documents. But if you look at the first document on the slide, this is a CERDIP-funded study which focused on assessing bias in sampling groundwater and surface water. And the second document was kind of practical guidance, very useful because it was written by practitioners, and it was published by the National Groundwater Association. So 2 quite useful documents. Both concentrate on the kind of perceived versus the actual risks. And as the general conclusion is that previous guidance has been overly conservative and the approach needs to be more kind of focused on science-based kind of conclusions and focus on what actually comes into contact with the sample. And the latest guidelines kind of highlights the need for a direct pathway for cross-contamination to occur. And there's in the second document, there's kind of a useful appendix which covers kind of quality assurance, quality control as well. Now, moving on to the case study that I'd mentioned, it's a confidential site, so I can't provide too much detail. It was a site that, as a lab, we worked very closely with our end clients to kind of develop particular types of sampling protocols. It's a site which was a very large oil and gas facility. It was subject to decommissioning and demolition. The intention on the particular site was to use a lot of the concrete. Some of the concrete was stockpiled and it was broken out from bunds and kind of concrete plinths, but there was a lot of intact concrete in place as well. And we tested a lot of the intact concrete. The site used foam pourers. These are kind of deluge systems. And we had to do a little bit of research onto what this actually involved and the levels of delivery from these particular systems. But we didn't have a lot of information about the formulation of the AFFF, which was actually unknown on the particular site. So these different types of foam pourers, they've got really high delivery rates in the order of something like 3,000 litres per minute. In US terms, that's about 800 gallons, I believe. And these systems are tested regularly, and an AFFF was released on this particular site to the drainage network. So that's the kind of context and the background. So what did we do? What was our kind of involvement? So we know that concrete can be very porous and PFAS can diffuse and partition and self-assemble on surfaces of concrete, especially after years or decades of AFFF contact. PFAS can leach from concrete over time and it acts as a secondary source of contamination. AFFF concrete slabs, they can certainly store PFAS and they can represent an ongoing source of contamination, especially to receptors like groundwater or surface water during rainfall events. So the combination of this kind of cationic and anionic PFAS, that enhances this formulation of these kind of multiple layers, and it kind of promotes that kind of stability as well. So these amphilytic kind of PFAS, they can aggregate, they form these kind of highly stable, multi-layered supramolar assemblies. And these are also called vesicles or lamellar sheets. So these kind of terms which are kind of used in the industry. So what did we do as a lab? We were able to determine that a lot of the mass of the PFAS was at the very near surface. So between the kind of 0 and 20 millimeters or up to kind of 30 millimeters, that was the majority of the mass of PFAS that we found. But PFAS didn't penetrate to any significant depths, but that's often dependent on how intact the concrete is. So this is a bit of a generalization. So if you're seeing a lot of fissures in the concrete or the concrete's broken out, that might not necessarily be the case. Interestingly, we analysed some samples and we found PFAS at the base of the core. We found PFAS at the top of the core, but nothing in the middle. And I think the explanation for those particular samples were that the groundwater was in contact with the base of the concrete. So that was conceptually made no sense. But when we looked into it, again, working quite closely with the client, that's what we found, that the base of the concrete was in direct contact with the groundwater. And that kind of gave us an explanation, and we had that confidence in the data. But that was only through that kind of conversation we had with the client. Now, the kind of diameters that we regularly receive in they tend to be about 100 millimeter diameter, and the samples up to a maximum about 15 kilograms, because anything more than that, it's quite difficult to transport those kind of samples. So again, you know, those kind of samples, the very surface of samples can be hand drilled on site. So if you were looking at kind of trying to identify where the mass was, you can actually use hand drills on site to gather up the dust, and the dust is then submitted to the lab and analysis is carried out. But the remainder of the concrete core can actually be, we can use a masonry saw, we can use a specialist crusher to manage those kind of samples. We also did some leaching tests of PFAS in concrete, and we often found that, yes, it represents this kind of potential source of long-term potential risk to groundwater from leaching of PFAS in concrete. It's not a source which will never change over time. It is a finite source, and it did change over time. But the release is often very dependent on the water percolation rate. We're kind of wrapping up in summary, and sorry, apologies if I've talked a little bit too long. As I mentioned, preparation and planning is key to the delivery of a successful site investigation. You know, this kind of common sense approaches that counts for an awful lot. You know, many people who are experienced, they work out on site, follow a very common sense approach. PFAS can form complex mixtures on site, especially in some soils and groundwater. And we need to have a robust and documented standard operating procedure when collecting soil samples, when collecting groundwater samples. And there's a lot of published guidance out there, but just be careful. Some of it is overly precautionary. We need to do everything we can to minimize the potential for cross-contamination, but focus on equipment and materials that are likely to come into direct contact with samples. And be aware of requirements of individual methods and how they might differ in terms of preservation, containers, holding times. We know that PFAS in concrete can be a secondary source of contamination on many sites, and we've kind of proven that from a lot of the work that we've actually carried out, especially in fire training areas. And maybe one final message: communication with the lab is really important. Please speak to my colleagues. They're here to support you. That's part of their day job. So please have that conversation with them. If there's anything you're unsure of, if there's anything unusual, if there's any kind of materials you need us to test, just please have that conversation with my colleagues. They're definitely here to help you. I've also provided some useful references. So everything I've mentioned in the presentation, I've tried to provide a particular reference to. If you wanted to know a little bit more detail, then there's some details in terms of the references that I used. So with that, I'll hand back to Alex and Morten for any questions that you might have.
Thanks, Geraint. We're going to open up the forum for questions now. If you could please write your question out using the Q&A function in your toolbar at the bottom of this webinar.
Right, thanks, Geraint. I'll ask you a couple of questions about the rest of the participants. I'll type in their questions. You talked about concrete. What about asphalt, which is also fairly typical in demolition sites and so on? Is there any point in, can you test for it, and is there any point of testing it?
Yeah, that's another real area of focus at the moment. I know there's a SERDP funded study looking at asphalt. If I skip back one of the slides, actually, it's I think it's the fourth paper from the bottom there. It's a really useful paper because it reviews all the different methods for analysis of asphalt, and that's what we based a lot of our methods on, actually, based on this particular type of paper. So I would refer you to that particular type of paper, particularly useful, I would say.
Okay, thank you. And then, I mean, a lot of the recommendations in the previous guidance was, clothing, makeup, hand creams and all that should be avoided at all costs. I believe the saying was you had to wash your clothes 5 times before using.
Yeah, that's correct. Yeah.
Are we walking away from those recommendations these days?
To a certain extent, I think it's more risk-based now. It's more looking at what comes into direct contact with the sample. And, if you went wearing sunscreen, for instance, then there's a question mark about you're getting exposed to direct sunlight there. So there's a health and safety implication there. So it's trying to draw a line between what is feasible, what's practical to do out on site, and what's not. And if it's something that comes into direct contact with the sample, I think that should be a priority. If it's not something that comes into direct contact with the sample, or if you can minimize that by following good sampling procedures, then I think we need to look at that, really. So yeah, there's been a move away from that, definitely, Martin.
Yeah, and I mean, I don't know if there's questions for, but I've got one more question which relates to the volatile ones, and that's a question I've had from some clients as well while talking to them. They're not included in any of the US standard methods, are they? With the one way we developed a method for reducing the GC MSMS. Will they be included in any of the US methods, you think, or will it require a very separate new method developed for it, like we have done?
From a soils and waters point of view, possibly in the future. From an air point of view, yes, I think definitely from an air point of view, but I think from a soils and water point of view, I'm not too sure. In Europe, there's a proposal to look at the fluorotalm alcohols. There's 2 fluorotalm alcohols actually, which are part of an EU requirement, and that's 8,2 and 6,2 fluorotalm alcohol. So we've had to develop a method, a low-level 5 nanograms a litre level method for PFAS in water. I guess when we get a bit more data, when we get a bit more information, it might be one of those classes of PFAS that we do need to look for, but it'd be based on kind of the information that's out there. So I think it depends on the information that we get from looking at these kind of new classes of PFAS. And it's very similar actually to the ultra short. There's quite a big focus in other parts of the world on some of the ultra shorts, things like trifluoroacetic acid. Yes, there's kind of a discussion about whether they're as bioaccumulative as some of the other PFAS, but certainly very soluble in groundwater. We're picking those up at much higher concentrations. There'd be a much greater class of PFAS. So there is some discussions in other parts of the world. But I appreciate this is a US focused presentation. So
yeah. So just to clarify, none of them are included in 1633 or 8421. Yeah.
No.
And the trifluoroacetic acid is also not included in any of the US standard methods.
That's correct.
Thanks, Geraint. I'll open up for if there's anyone else, Alex, has got any questions typed in there.
Yeah, we do have one question here. Since PFAS are generally a collection of forever chemicals, is there still research that needs to be done on certain PFAS that are more toxic or more prominent within areas that are observed?
Yeah, I think there's just a long-term initiative to look at broader classes of PFAS. I think that I remember seeing the latest kind of definition of how many PFAS are out there. It's 7 million PFAS. I noticed in the PubChem kind of database. So there's just a huge universe of PFAS. We're not going to be able to test all them. We're not going to be able to analyze for all them. But perhaps that's where kind of non-targeted analysis might be particularly relevant. Things like high-resolution MS. Those kind of techniques might be particularly useful to maybe analyze as PFAS as a class, as a group of compounds, as a group of substances. But they're developing toxicological assessments that have been done on a broader range of PFAS. And I'm sure that will be the case in the future as well. So it's an ongoing research and development area, I would say. I think if I was a toxicologist, I think I'd be in a job for life, I think, with PFAS at the moment.
Thanks. I'll give just a couple more minutes for people to submit their questions, and I'll go over some brief notes. This webinar presentation has been recorded. All participants of this webinar will receive a follow-up email once the recording is available to view. We also post our webinars on our ALS YouTube channel in the webinar playlist, and I encourage you to find a wide range of video resources, and some of our past webinar presentations are also available there. Please follow our company page on LinkedIn as we post announcements and registration links to future webinars and other valuable resources and updates. And I don't see any additional questions coming in. So looks like Geraint covered pretty much everything, I guess. I want to thank everybody for attending today. Again, you can contact Morton or Geraint for any questions. Their contact details will be included in the follow-up email. And it looks like we do have one more from Isabel. Until we figure out which is which, just like any chemical, is there a natural solution for these? I suppose until we figure out which is which, just like any chemical, it can have a natural solution for these forever chemicals to dissolve, which is why it is important to analyze as many as possible.
Okay, so I guess it's a question about, Alex, I think it's really useful having kind of a technique which is a non-targeted analytical technique, and there's I guess there's a place for that. You know, there's regulated PFAS, and those are the ones we should be looking at. But it'd be interesting to see from the kind of unregulated contaminant monitoring round what comes out of that, what the kind of latest information is from that as well. But there's certainly developing research being looked at. When we've done non-targeted analysis, we've found a lot of PFAS that we would have missed by looking at just a targeted list. So I know certainly in other parts of the world, they've used non-targeted analysis to determine what should be regulated, what is frequently found. Just to give you another example, there is one particular type of PFAS, which is a constituent in firefighting foam, which we're picking up at really high concentrations, really high frequency. It's not regulated, but we developed a kind of a non-targeted method for looking for this to begin with, and now it's part of our kind of standard suites called 6.2 FTAB. So as I said, it's a constituent in firefighting foam. It's found at quite high concentrations. So maybe that might be one of the PFAS to look out for in the future potentially. And it might be regulated as well. I think the US EPA are looking at the toxicology of 6.2 FTAB.
A follow-up question to that, Geraint. You talked about the top assay earlier here.
Yeah.
How good of a solution is that to tell you the whole truth about the site? Will it give you everything?
Not necessarily everything, because the way the top assay works, it'll just be a list of individual PFAS. So it's not going to tell you, well, we don't have a standard. It's an indirect measure of PFAS, but it doesn't give you the same level of information that kind of HRS-MS would give you, for instance. So it's useful, but it can be used in combination with other analytical methodologies. So it's kind of almost like a toolbox approach where we're looking at total organic fluorine, we're looking at AOF, EOF, etc., to understand that kind of mass balance, that fluorine mass balance. So a combination of these techniques might actually provide us with a lot more information on whether top assay, for instance, is picking up a lot of the mass of PFAS or whether it's still missing it. I think it's a really useful technique and it's been out there for a while. I think there's room for improvements. I know there's been some published studies on top assay starting to look at combining top assay with the ultra shorts, for instance, because you can get that kind of sequential unzipping of PFAS that wouldn't be picked up by the standard suites that would normally look for under top assay. So it's certainly got a place, and I'd say it's very useful. I've found it particularly useful on a lot of sites that I've been involved in where there has been AFFF impacted soils and waters. I think it'll develop, and I think there's other approaches there. Things like UV activation with top assay as well. I think that's got a place too. So there might be some data quality objectives. Again, it's one of these things where we need to look at the data quality objectives for top assay. So if you've got these kind of data quality objectives which are published, and as a lab, we do use those data quality objectives. ALS do use those data quality objectives before releasing the data, but it's that extra kind of level of quality assurance over the results that you have using a lab like ALS.
Thanks.
All right. If there's no more questions, I guess we can go ahead and close this out. Again, I want to thank everybody and hope you guys will enjoy the rest of your week. We'll send out the follow-up email after this webinar. Thanks.
Thank
you, everyone.
Thanks. Bye-bye now.